What's the definition of his definition of deep medicine?
It's not replacing human with AI, right? Machine learning, but rather augmenting it. Because he's making a point that like if you compare AI to US insurance companies, right? They can just reject your subscription to a drug just because they think it's expensive, right? They say they don't need it. I mean, I've seen things on Twitter, like medical doctors saying, okay, I have cancer or something like that, and I have been prescribed this medicine, but the insurance company denied it, right? They said, contact your doctor. But yeah, that was the doctor that prescribed me this medicine, right? What's wrong? So he kind of also compares this AI in medicine to insurance companies, right? That they can be too strict, right? They need some human factor there. And he says that...
What means too strict? You mean the insurance companies or...
I mean, the insurance companies are strict in a way, but also like if you apply AI only to treat patients, right? You will not have this human factor there when you have a doctor that can,
of course,
so recognize some other things.
AI together with the medical doctor to...
Yeah, so he said that, that AI machine learning should offload doctors so they could interact more with the patients, get to know their patients more. Because it's not only about the symptoms, right? It's also like on your living habits.
And this has been a core theme on this podcast, that is sort of, when we meet a lot of guests, that augmentation of intelligence, or how does AI interact with human, is the way to go in many areas.
Yeah, and I haven't heard about this person, Eric Toddle, before, but if he says that, I think he very much agrees with that.
I need to check.
It would be fun to hear if you agree. Something that we have been saying for a long time is basically that, AI, of course, can go through data in a very efficient way, but perhaps not always the most effective way, saying, it doesn't really have the deep understanding and background knowledge that humans have. But humans, on the other hand, can't really go through like hundreds of MRI scans of the heart or whatever kind of cardiology kind of use case that he's working with. But AI can do that. But then, to truly interpret and, build up a treatment plan, you need the expertise and the deep knowledge and background knowledge that human doctors have, right?
And the whole interaction.
Yes and no. Sorry, you can have also a lot of misdiagnosis, right? Because
from humans or
from humans.
Yes.
Because humans treat their job very routinely, right? I had a problem with a shoulder, and I went to a doctor, and first thing he said, like, let's do X-ray. But that was I need really a physiologist to look at it, and prescribe some exercises, right?
Yeah. But it's this topic then that machines can be really better at some parts, but there is a huge also human part or empathic part of being a good doctor. So this whole augmentation idea has many angles. How to maximize the benefit of AI.
But also replacement would have big benefits. You can treat this machine learning AI as a transfer of knowledge from rich countries to third world countries, right? Like with this whole that's kind of popular use case when you have that Google or others trained model that works on pictures of the, how do you call it, deep part of the eye, like the back of the eye, retina. Yeah, and that performs as good as optometricians, right? And that can be used in the third world countries when you don't have access to that many
I think that's an interesting point, that developing countries can really jump some of the technical steps that we in the Western countries otherwise had to go through.
Yeah, they can leapfrog now. And I think, if I understand Toppel's idea, is also here, he's using technology to drastically reduce the cost of, if we take this scanning the
another example, one of the things that he thinks will be a big step in the future for also third world countries is portable ultrasound scanners.
Exactly at this point.
All right, because at the moment those devices used in hospitals and medical centers, they are quite expensive. They cost like tens of thousands, if not hundreds of thousands of euros. And this kind of portable scanner you can plug into your mobile phone, and I think at the moment when I checked it, the one cost like 2,000 euros. So it's like magnitude of price reduction. But what Eric did was he scanned his whole body with this portable, portable ultrasound scanner. He found something. I don't remember what was that. Something with heart also. But in general, the problem with ultrasound scanners is that you have to know how to put this scanner head against your body because, basically what it does, it sends a sound and receives it back. And depends what it bumps on, you'll get that in the picture or not. Right? If there's something between the scanner and the object you want to scan, you will not see it because there will be a shadow from a bone, for example, right? If you scan between the ribs, right, you will not see the organs from the inside. So you have to know how to scan it, and that's where AI probably could come into place, right? It can measure how are you holding the scanner against your body, and maybe can adjust. Yeah, you should move it, or maybe you should do the whole movement, and it will pick the right pictures.
Like we do now when we scan. When we start off.
I mean, I guess it's just like third or developing countries can skip some of the communication thresholds, like having landlines. There's no point in doing that. Let's just jump to mobile cell networks and so much more quickly and more cheaply be able to have communication networks throughout.
Or we can go one step further. Like I think in Nigeria they don't trust the banks at that much, right? So they are using bitcoins
they rather do bitcoins from the beginning. It's interesting.
Let's not go into Bitcoin. I don't know. I'm sure we want to go there, but it's a good example.
But let's introduce Marcin. And now I will not butcher your name. So we start here. How?
Okay. So
who we have as a guest
my
today?
name is Marcin Pękalski.
Marcin Pękalski. And all the listeners should know I practiced, and I still feel I butcher your name.
It's quite good.
Yeah. But we have a Kaggle master here today. So I think that will be super cool to have a general theme to understand what Kaggle is all about and
competitive machine learning.
Yeah, competitive machine learning and tie that back to what Kaggle do and how it works and all that. So we will have many interesting angles on that we can tie into our different topics we talk about. So this is a Kaggle theme to some degree. Let's see how that works out.
I think it's a big honor to have a professional like that and someone that I think can give a lot of tips and tricks.
And what is Kaggle? What is Kaggle?
And what's the pros and cons of being, using Kaggle competitions versus real world applications?
So but let's start. Who are you? What's your story?
What's my story? Oh, my story is not that long in comparison to others. But I was born and raised in Poland. So some people say it's Eastern European country, but it's more in the center than in the East. I studied there math and economics, and that took me quite a while, 7 years in total. Then I worked in different places, like in telecoms and banks. I worked in UK in a bank. Then I moved to Sweden. I worked in a gambling company. Gambling. Yeah, they were doing slot machines for online website, online casinos. And now I work at Kambi, who is a B2B sportsbook provider. B2B and sportsbooks are keywords here.
But going back to some of your education as well, and you focused a lot on math in the beginning. Did you focus on some specific piece of math that you had some extra passion for?
I like the most analysis, right? Mathematical analysis, real and complex. And I wrote my master thesis in numerical analysis. So it's not really machine learning, but some algorithms. And in general, math, when you study math, it doesn't teach you any kind of, it doesn't prepare you for a job, right?
That is what I was trying to get at, but I think it's actually a misnomer a bit because it perhaps does in ways that you don't think of. I actually have a quote for one of my favorite math professors, and basically said, you don't learn math to have use for it. You learn math to show that you can do it.
That's a very good point.
I'm not sure I agree with it, but it's actually true in some ways. But a couple
of years after graduation, you don't remember that much, so you cannot. You showed that at some point you were able to do it, but it might not be the case anymore.
But for people there are a lot of people interested in math, including myself. So if you just were to, did you do a bachelor or something in some specific?
No. In math, it was probability theory, right? What did I do? My studies were, there was at my university, a lot of people were studying math and economics at the same time, right? Mm-hmm. And they had to kind of juggle the balls between like one and the other faculty. So they created a joint program. So for bachelor studies, they prepared like a set of courses that you had to do, and you could get a diploma from joint studies. And then after that, you could pick what do you want to do next, math or economics. Yeah. And majority of people picked both. So for bachelor, I was studying both math and economics. In math, I did bachelor in, I think it was also analysis. I don't remember at the moment. Because you have some core courses, right? And then you just select one topic in which you write your bachelor thesis. But it's not
something in periodic functions or something that you worked with?
No, periodic functions was a master thesis. That was differentiability almost everywhere of some set of functions. I don't remember.
Okay.
Yeah.
Rademacher's
functions. And then you started. You were. Yeah, you worked in the telco space, and then in the end, where were you in the telco space?
It was Orange, so that's the biggest telecom in Poland. Subsidiary at the moment of French Orange, right?
Yeah.
They did the bigger branding. I worked in reporting, BI, so business intelligence, however you call it, depends on the company. There we used a lot of SAS.
SAS Institute stuff.
And for people that don't know what SAS is, how would you describe it?
It's a big statistical software that can. You may compare it to R, or I think R is the best one.
R is the closest, but SAS is the application where R is more the open source approach.
Yeah, but the main difference, SAS is commercial, R is open source, and I think a lot of telecoms and insurance companies are using SAS, and also banks.
So in enterprise minor.
Yes.
Yes.
But what I heard is that because SAS is a commercial company and they give some guarantees behind their algorithms, right? And you have the support, which you don't have for open source. Mm-hmm. So that's why those big enterprises use it. Right, and they can hook up to pretty much any kind of database.
What's your pros and cons about that? If you were to start your own company, would you make use of SAS or something else?
SAS would be too expensive. I think if you start a company, so that would be R or Python. Depends what skills you get on board in the company.
Of course.
Yeah, and then after, so you did that, and
Then I moved to. I worked for some consultancy that sent me on a project to UK, where I spent 2 years in MBNA, that's a subsidiary of Bank of America, and there I also work in SAS. So I think that's why they got me there.
Yeah, and then in Sweden, was it Unibet? You ended up at the beginning.
First company was Net Entertainment.
Okay,
so they create a casino game. Casino games for online casinos. Okay. It was the slot machines, and they also had a product called Live Casino, when you have live dealers dealing blackjack cards or playing roulette with people, and they are filmed.
Yeah. And your role in your work,
not Russian roulette, right?
No.
Polish roulette.
Not that I know.
I don't know that.
My role, I was a BI analyst there, but we had one person who was doing our data warehousing. That was I think the fastest onboarding I ever had, because I started to work in July, and I don't know if all the people who are listening to the podcast know how July in Sweden looks like, but it's pretty empty. We had in the Swedish office of Net Entertainment, there were 200 people, right? But in the summer, there were handful, maybe. So there was pretty much no one there. And they told me, okay, you see, this is Henrik. Henrik is managing our data warehouse, and he's going on holidays next week. Yeah, you have to cover him.
Really?
and in Sweden, people go in the summer on 4 weeks of holidays. Yeah, that was
at least.
At least.
The deep end.
What kind of warehouse tech stack did you have there?
That was Microsoft SQL Server. And I mean, Net Entertainment had quite a lot of customers, so the main job was to get the data in the morning from like 150 different databases and synchronize them. And and that was, as I said, the fastest onboarding I had.
Yeah. So
you have to cover him.
Batch, I guess, at this point in time.
Yes, that was batch.
And you run out of time to get the batches in on a daily basis, right? Not really.
It was not that bad.
Not that bad.
Sometimes it took quite a while if you lost some connectivity to the servers and you have to reload, but everything was pretty automated.
That's good.
And maybe later at some other stages we had to optimize our tables for querying because they got pretty big.
Did they have their own on-premise machines? Or
yes, everything at that time was on-premise.
Yeah. Well, and then when are we talking now? What year, roughly?
That was like 6-7 years ago.
6-7 years ago. Yeah. And then what was the next step? Because I think
the next step was Kambi, so my current employer.
Yeah.
So it was one thing I tell sometimes that's like I was asked like why do I want to switch a job, right? And I said I don't really care what the company is doing. I'm here for the data.
I love that comment.
Because I mean at Net Entertainment, I mean the data was not that big variety, right? Because people click to have those slots spinning and then get the outcome, right? And Kambi is a sportsbook provider. So the company allows people to bet on sports. And then we have hundreds of not hundreds of sports, but tens of sports, right? And that creates a big variety.
What's a
sportsbook? So we allow people to bet on sports, right? So you can bet. The simplest way, you have a football match and you bet if Manchester will win with Liverpool, right? Or if there will be a draw. And beside that, we have many different offers. I mean, what people can bet on, like if the total number of goals in the match will be over or under 2.5, or will there be a red card in the next minute? Or that's example from soccer, but you can also bet on tennis, and then you can bet on every single ball that is being served, like who will win. And so
it's done in real time, and people just start betting in real time on every ball being played.
Yeah, people do that. That's in some countries, like in Australia, they consider that as gambling a bit because it's similar to the slot machines. But I mean, there are skills to that also.
Perhaps you can't really tell, but if you were to recommend someone that wants to go to Kambi and make some money, what type of betting would be preferred, or do you think they have the biggest chance to quickly get into
it? It depends on the skill, right?
There's skill on the knowledge of the sport.
You can have a knowledge in football, right? American football, and it's not applicable to soccer, right? So it really depends.
So you should choose something that you have some experience or knowledge in, and then try to make.
Yeah, but I mean, a lot of people probably are doing that for, let's say, social reasons, right? They are big supporters of Liverpool, so they go behind the team always, right? So they will bet on the team.
And you're in Europe and in US, right?
I mean, we have operations all over
all over.
Yeah.
So are you typically operating under your own brand, or you are an engine under other brands?
That's a B2B company, so it operates. I mean, we provide a solution, Sportsbook as a solution.
So Sportsbook as a solution, that typically there is a local brand.
So
you are the engine.
Like in Sweden, you asked about Unibet. So Unibet is one of the clients.
Of your clients.
I mean, Kambi is a spin-off from Unibet, so it started at Unibet, but now Unibet is a client.
And this is the point you make, sports booking B2B. So basically you are building and working with the engine, so to speak.
Yes. So.
And who are your biggest customer? You mentioned Unibet. Are there some other big customers you have?
888 and DraftKings. And I mean, there are a lot of customers, right? But most, like in Sweden, I think the most popular are Mr. Green and Unibet.
Yeah.
I mean, I don't have TV, but people keep telling me that
you're always on the TV.
Yeah, they're always on TV.
But and how would you understand or define your unique selling? What makes your engine good? How what is your why is it used? So it's used quite a lot.
I mean, we are good.
I know you're good. I know you're really
the
good.
idea he is not can't go into detail. He's saying, what's your strength, Henrik? Can you please tell everyone else so they can copy you? Or
Okay, I tried it. Don't answer it. It's okay.
Needless to say, I mean, they're used by the biggest kind of
brands
today, so they must have some good technology behind it. That's
and what's your work now in this field?
I'm managing the Kambi data science team. So there are a couple of people who are doing data science there.
And what's the main use cases, so to speak?
I mean, we do many different things. But
I can imagine.
Sorry, I cannot go into details.
No. I realize we're going into...
but you can do a lot of stuff, like from risk to analytics, for reporting even.
Yeah.
And,
I'm not so eager to go to the Kaggle part, but let's, before we move there, I mean, you have a data science team, and recruitment, of course, I guess is important always for them. Do you have any special tricks for how to perform recruitment to find good talents to come to your team, for example?
Or maybe we're just lucky that we got good people.
Sorry, what?
Maybe we're just lucky that we got good people. Yeah. I don't have.
You don't have any personal tricks in the way to do interviews or what you look for in a CV?
Not really. I mean, I'm quite picky regarding CVs, so I mean, I really don't like this. It's very common, like people making mistakes, like spelling interpunction. Like for me, it's like people not putting attention into details or didn't have time
to have somebody's mistakes in the CV. Would that be a negative thing for you, or do you don't?
That would be a negative thing.
Yes.
Yeah. I don't like them. I mean, it's kind of funny because as a kid, I mean, I'm dyslexic, and I have also I was really struggling with spelling mistakes in Polish language, right? Polish language is very tricky, but I was making like dozens of mistakes per page of handwritten text. That depended a lot on stress, because I mean, without stress, I could write without mistakes. I knew all the rules and all exceptions and so on. But when, for example, time of exam came, I was going with the number of mistakes through the roof. So, so it's kind of.
But you, as a Kaggle master, and you have been so successful in different competitions there. What would you say the value is if you see someone else being successful in Kaggle competitions? Would you place a lot of value in that when recruiting?
I guess I would. In a sense, those people that are taking part in Kaggle, a lot of them, I mean, those that take it more seriously than just register and make a sample submission, they do like to learn, right? Most of them are there for learning.
Or to make money?
I guess it's too hard at the moment, and prices went down a bit, and you have to be really. I mean, sometimes even with those big competitions with big prizes, not everybody got them that had a winning solution. But we can talk about it later.
You mean even the person that should have won it didn't win it?
Yes, for example, there was a competition sponsored by Facebook. It was about recognizing, I think, deep fakes in videos. And one of the teams that was, I think they were winning, or at least top 3, so they were in the money. They took examples from like screenshots or from YouTube videos, and Facebook, I think, said that they didn't have a license, like they didn't have release notes from those people, right? So they really couldn't use the images, so they should be disqualified. They didn't get the prize. I don't know if the main prize was like $1 million or something, but that was significant.
So they brought in external data that they couldn't really have licenses for? Or?
I mean, they assumed that they have the license because that, I think, some of them were under CC, right? So Creative Commons, but not all of them. Or maybe they couldn't provide like links or something.
So they failed on a bureaucratic rule.
Yeah, I think they assumed that they had the rights to the images because they were under Creative Commons, but they didn't have like model release or whatever you call it when you take a picture of a person. Yeah.
But maybe we should set this up and go to this Kaggle topic now, because
but let's close the recruitment part a bit. I think because Kaggle competitions, of course, is one thing. What do you think it demonstrates in a person if they do compete and do Kaggle competitions? you think it's curiosity? Do you think it's like they have the like practical knowledge and know how to perform, or what kind of personality do you see if someone has done that?
Okay, putting aside the knowledge, right? Because some people have it, some don't, and you also can create a team, right? And then you can team up with people who have the knowledge, and you have some other skills. But in general, you need to structure your product quite well. You have to be able to iterate fast over new.
And now we're speaking about the product that you have, for example, in Kambi, and that you should look for people in a team to move the product, or what kind of product do you mean?
I mean, not product like in a model, right?
Data science product.
Like a model, like an AI model kind of.
Yeah.
Okay, sorry.
Maybe I'm too biased with working now and haven't touched Kaggle for a couple of months. But so when you create a model, you need to be able to iterate quite fast and be able to tell what happened in the previous iteration or a couple of iterations back in time, and be able to go back to them. So you also need you kind of need a structured approach to solving the problem. Very often you need to be able to read up on the latest state of arts, even if not the methods, but then also learn fast about the field you are developing the model for. For example, I mean, one of the competitions I took part in was there were data from satellites, right? There was so you had to learn how the satellites works. Yeah. Maybe not work, but yes.
You have to have the basic domain knowledge fast in order to do the modeling.
Yes. I mean, not for every competition, because some of the competitions, they try to anonymize the data. So there was one competition and they provided 600 columns and they were named from X1 to X600. And then, no domain knowledge will help you. But you could find some data there. Okay.
I think that was an interesting point, domain knowledge. So, I mean, for one, you say that the person that has competed in some kind of Kaggle competition, they do provide at least, they have the ability to quickly gain some knowledge about some domain and make use of that, right, to win the competition, and they can read up quickly in how to do something, right?
Yeah.
What else? If we were to find something else still that you would look for in a person besides being able to compete in Kaggle, would domain knowledge, for example, in some field like medicine or something, be something that you look for? Or how would you, besides Kaggle competition, look for skills in people? Or is it only, as long as you have done some kind of Kaggle competition, you're fine?
No, not some kind of,
But it's about
you need to be consistent, right? Because a lot of people sign up, they may do one competition and then disappear. That wouldn't go they wouldn't go through the filter.
But how do you value sort of core tech skills based to more analyst or business to problem to data model translation skills and all that?
I would say it would really depend on the size of the company. I mean, if you have the money to hire data scientists, machine learning engineers and others, then that's a different skill set than you would require from one data scientist that has to do the whole stack, right?
A full stack story versus a really diverse team.
Because if you look at what kind of code data scientists usually develop, it's like a wall of text, right? It's not maintainable. And if you have a production system somewhere, you need to make this code nice and clean and easy to maintain, test. Yeah. I mean, what Kaggle doesn't teach you is unit tests, right? You don't have unit tests. I mean, you kind of have them in a sense of this.
I think that's a bit what I'm getting to. I mean, it's a different thing of doing Kaggle competition than actually putting a model or some kind of system in production, right?
Yeah, but then depends on the size of the company. Can you afford to have those people that will put the model in production, or you need somebody who will do that?
And what size are you? Do you need unicorns, or are you big enough team so you can sort of be good at different skills?
We are somewhere in between, I would say, because I mean at the moment, I would say the data science is not in the core of the business, but we are kind of growing, so we are developing this skill set to put stuff in production, right?
Yeah. So have you seen? Toolkit. Does that mean that your team in some ways has evolved to becoming more and more, how should I put it, an operational, production-oriented team that you can do models, we can do analysis, but and then we started here, and now we are growing more and more from data science to MLOps, proper.
I mean, I don't know if it's due to regulations or not, but we have some dedicated DevOps teams, right? So developers shouldn't touch the production servers, right? They cannot do that. So they have to develop the code that is that will run straight away with just maybe small changes to config files.
Yeah.
Right. But I mean, I think it was Klarna years ago. They had like data scientists that were writing stuff in Python, and then they had dedicated developers that were translating that Python to Java and then putting that in production. Yeah. So we don't want that.
Thank you.
You don't want that, right?
I'm so eager to speak about Klarna, but Klarna is a great company in many ways. One of the most successful companies that we have in Sweden, actually. But they also had some challenges in the past.
Yeah, but I've heard that they moved away from that. Step in the middle, right, between production and data scientists. Right, they don't have this translation to Java.
Yeah, cool.
But should we move to? Yeah. But let's then move into Kaggle, and I think we need an introduction. What is Kaggle? I mean, like for the tech nerds, I'm sure we know, but I don't know in detail. So please introduce me to what is Kaggle and what it's all about and what's the background.
Kaggle is a platform for, how do you nicely put it, competitive machine learning. So companies can put their, I mean, of course, there's a big process behind it, but it boils down to putting a data set on which and some metric that people have to optimize for, and they are given aim to create a model that will solve some problem or optimize the metric, right? And I don't remember how many years ago it started, but more than 10, because I just checked my profile and I think I had like 10 years. I registered 10 years ago.
Can we have a look, Goran? Kaggle?
Kaggle, yeah. So it was bought a couple of years ago. Founded 2010. So I registered like 1 year after they were created. But they were bought by Google.
Yeah.
So
what do you think about that? That Google bought a company like that?
At least they have money to run. Right?
Yes, that's good.
So they will not run out of money.
Yeah.
And they have money to develop, right? So they created this, what they called Kaggle datasets, for example, that people can put and host their datasets there.
Yeah.
I mean, probably it benefits Google in some sense.
But do we know how big the community is by now? Because Kaggle, this is quite huge worldwide.
I remember at some presentation, the founder was saying that they have around 1 million people, but I don't know how.
It says, Wikipedia says what?
Registered. That was in 2017, but not all the people that are registered are active.
Active now.
And also I know that universities can host their own competition, like internet for the class, right? So not everybody competes in those public competitions. Maybe they just register to get the data set, for example, because in order to get the data set from a given competition, you have to register and accept the rules, right? So,
but I guess in short, you can say that companies can actually put up competitions there, and they can put up some kind of prize. That
it costs some money, of course,
yes,
because you need some data engineers or data scientists on Kaggle side to help you to prepare the data. Because some people.
And so we have some examples of a little bit bigger prize monies, even like Facebook's put up competitions. So what's a big price that has been out? What is like $1 million?
$1 billion.
Dollars,
yeah.
For the winner of the competition?
No, I think that was pool price.
Pool price.
Yeah, but I think the first prize was $500,000.
Yeah.
And you can. I mean, many people may know like the Netflix challenge. That was the previous. I think that was the source of
Netflix
the idea.
prize.
Yeah, Netflix prize was the source of that.
Which one was this? Tell us about this. I don't know this.
That was in. I don't remember the dates. Early 2000s, right?
Yeah. 15 years ago or something, I think.
Yes, I think that was in the beginning when Netflix was still sending videotapes.
So this was the precursor to
Kaggle.
Can you Google Netflix price? Netflix price?
Ages ago.
But this was outside of Kaggle, right? That was,
that was. Yeah. You may say the base for Kaggle.
Yeah, exactly.
Netflix price.
Not if you stock price.
Now this was in what year? It was.
2009.
Okay, so 11 years ago, right before Kaggle.
Right before Kaggle.
And this is an interesting challenge in itself. It was like $1 million, right?
Yeah.
And it caused a lot of upset. And I guess the winning prize, and let me jump into some technical topics here because it's interesting, I think, in itself. The winning person, what was the outset again? It was something like if they could beat the existing baseline by like 10% or something, they would gain, win the prize.
Yeah.
And someone, after it took a number of years, if I remember correctly, before they were able to do it. But then someone did it, and they won the money. But it turned out that the solution was not really useful for Netflix, so they never made use of that. It was a huge,
too complex.
Yeah, huge ensemble kind of models, right?
Ensemble, and I think matrix factorization. So
I think it was like a huge ensemble of many, many models. If I remember, I may be wrong, but I think it may have been. In any case, this is one of my hate topic and favorite topics at once. What do you think about ensemble models?
You cannot win a competition on Kaggle without ensemble.
So, this is perhaps the downside of
Kaggle. But on the other hand, Kaggle really popularized those, right? Yeah. And also they say that like ensemble of top 10 models is better than any single one of them.
So what is a simple definition of an ensemble model?
Average of predictions. So you have like two or a couple of models that are, let's say, independent. They may use some different features as input or not. But the idea would be that they
put them together.
Yeah, you put them together, average predictions from both. And then they are usually better than any single.
So it's good to tune for a specific test set, but is it useful or to put ensemble models in production? Is that the core question? Tricky?
I would really say it depends.
Yeah, it depends.
I would say never. But okay. I'm a bit biased here as well.
So it's one thing how you can optimize for a score that is not always as easy to run as an operational production environment. Something like this. What do you think?
Could be. Kaggle takes it to extreme, right? So winning solutions sometimes ensemble like tens or hundreds of models, which is maybe a bit too much. But I think if you ensemble like 2 or 3, then it could be even good for production.
2 or 3, yeah.
2 or 3, yes,
not
but
hundreds.
not hundreds. Yeah. and in one of the competitions I took part in it, so it was we took ensemble of different checkpoints during training. So at the training, you just do a checkpoint, train for a couple of more hours, checkpoint, and ensemble of those was better than any one of those checkpoints, right? So depends. Do you need this edge, like 1-2% of accuracy?
But let's take this as a much deeper example now. So when you're a Kaggle master, what has been the competitions, or which one has you succeeded with or won, or what was your claim of fame, so to speak?
The highest I got was the in the money prize for one of the YouTube competitions. So there, YouTube provided data with the framing of the competition was also quite complex, but in general you had some kind of data about the couple of million videos, and you had to assign tags to those videos, right? So what is in the video, basically? This data was pre-processed by Google, and they tried to shrink it a bit, but still it was like 2 terabytes of data. So that was the most interesting part of the competition.
So how did you get the compute resources necessary to actually work with that type of data?
So it was not a problem to run it on a desktop, right? I had to buy
terabytes of data.
Yeah, 2 terabytes. So I had to buy two more hard drives, but
you run it at home
to parallelize.
Come on,
reading from one and writing to the other. But I teamed up with 2 other guys, and one of them was doing PhD in Spain, I think, as far as I remember, and he had access to like 20 GPUs. So that helped us.
Yes.
20 GPUs could help.
Yeah, one of the advantages. That's one of the advantages when you do Kaggle competitions recently. When you have to iterate fast with your ideas, right? To be able to scratch them off the list.
And then you want compute power in order to test your ideas fast.
Yes. And before then, running stuff on AWS or Google were too expensive to do it. I mean, they provided some credits like $100 or something in compute or 1,000, I don't remember. But that was not enough. That was enough to train one, maybe two models, but not when you have to do like 50 to win the competition. Right?
So if you were to go a bit into depth in what your solution was this for the video understanding challenge one, or which was it something else? Or
yeah, that was video understanding challenge.
Yeah.
So.
Can if you were to describe your model that you were so successful with, how did it work?
Oh my. I mean, first you have to understand how the data set was created. So what YouTube did, they took a couple of million videos, I think it was 7. And then for each of the videos, they cut it after 3 minutes. And after each second, they took like a screenshot, right? They had an image. Then they ran this image through Inception v3, so kind of image recognition network. And they got some, and they cut off the last layers of the Inception network. So they didn't get
the Inception model that was trained on ImageNet,
yes,
and then you take the last layer to get some kind of feature vector out, right?
Yes. So they didn't get the predictions, but they got the feature vector.
Yes.
And then they ran this feature vector through some PCA to reduce the dimension,
yes.
and still they ended up with 2 terabytes of data. And
So
they did. Sorry,
I just want to stop there. So feature vector used a little bit. So I follow a little bit. So we continue the story. I just want to feature vector we are sort of compressing to much less.
I mean, in short, neural network has a large number of layers, and every layer outputs a set of numbers.
Yeah.
And the second to last layer, before you actually predict what classes it should predict, is simply a set of 1,000 numbers or something, whatever the size was,
which is called
a feature vector. So
a feature vector.
It basically extracts features, something that describes the input data in some way, and that can be used for other tasks. Right?
Okay, so back to the story. So I follow.
So they compress this. So for each image, you get like a vector of 1,024 values, and they did some similar stuff for audio for the videos. They didn't disclose what algorithms they used or anything, but they had they outputted similar feature vector, a bit smaller. So we had these 2 pairs for each video. Had a list of features.
Video, audio vectors, feature vectors.
Yeah, and that was for 7 million videos. 5 million were in the training set, and I think 2 million were in test set, right? Because how Kaggle works is that in each competition you have this training set that you train your model on, and then you have a test set on which you don't have this target variable that you're trying to predict, right? And you make predictions on this test set. You get some kind of file with for each, let's say, ID of the video, what kind of tags you would predict that this video should have, right? That's your what we call submission file. You submit that to Kaggle. And then on Kaggle, you have they divided this test set into two parts, public and private. The split, it depends really on the competition. Sometimes it's 50-50, sometimes 70-30, it depends. And the public part is the one that you can track pretty much in real time during the competition. So you make a submission and they score it, and you see your score on the final metric, right?
Yeah.
Immediately. And the private one, they do it after the competition finishes, and that decides on the final standings. So who will win the competition? And when you do Kaggle competitions, you are also limited to the number of entries you can do per day. So 3, 5, really depends on the competition. But yeah, sometimes even in this YouTube competition, we didn't manage to use all 5 a day, right? Because running a model is like a day sometimes. So yeah, you do one submission.
Okay. So what model do you use? You have basically as input then the output from their feature vectors, right? Mm-hmm. And then you wanted to make what kind of, you had a set of tags, like one hot encoded tags, or was it a multi-class kind of classification?
That was multi-class classification. Mm-hmm. But yeah, I mean, to save us space, in the predictions, when you train the model, you one hot encoded. But we created a lot of different features from those feature vectors. I mean, like typical statistical things like mean, variance, some deviations, min, max. average. And then what did we do? I think we did some 3-layer neural network with a mixture of experts. So yeah, I think that, and we did a couple different flavors of neural networks. I mean, like different width or depth.
But just the feed forward, like dense layers,
yes,
basically
yes.
on top of that.
Yeah.
Okay.
Maybe some code. I think it was mostly fully connected even. Because that, even though it was quite expensive, but 3 layers was enough. I think 3 was the max. 5 or 4 didn't improve much. I mean, that was a couple of years ago, so I don't remember all the details. But
I don't think you want to reveal it. I think actually you do know very well, but you just don't want to reveal your secrets.
We wrote ourselves. I mean, many people when they finish and they are in the money or like top 10, they write down their solutions and they put it online on archive.
Okay.
Or
so
somewhere.
Did you do that as well? Or?
Yes, we did. So
okay.
Our solution is published there, and we also were invited to present it on some conference. What was that?
So were you like the number 1 or top 3, or do you remember?
3 or 5.
Yeah,
I don't remember. I think in the beginning we were 7th, but some teams got disqualified because that's another thing. Like, I mean, when you do Kaggle competitions, you are not allowed to communicate with other teams outside of the official forums or something like that. And I mean, someone did. I mean,
do you know how many that participated in this specific challenge in total?
I think there were like 300 teams. I mean, those really data-heavy competitions, when you have 2 terabytes of data, they don't attract that many people. People are afraid of the size.
Yeah. People are afraid of data. It's another title or T-shirt.
People are afraid of data. I love it.
Yes.
But as a very stupid question, so what's the actual thing that you're trying to score? You're trying to predict what type of video this is, or classifying videos?
What is in the video.
Yeah. What is in the video?
Yeah, and I mean, the metric was quite complex. So you had to predict a set of labels that, I mean, the tags that you usually see under videos. And they had some score like something related to the position of the label and is it correct or not. I mean, I don't remember.
So the ordering of labels was important as well?
Yes.
Oh, okay.
So you should basically predict in the end what you spit out. You should predict what is the tags that Google would use for this video.
Yeah, you cannot predict everything to be Minecraft, right?
No, you could.
Maybe back into
and you used some kind of mixture of experts, you said. So in short, it was some kind of ensemble model of different other models that you took an average for, or how did that work?
That happens automatically, like within the model, right? This ensemble. But then we assembled different checkpoints and different models.
Yeah, I did that as well. I see.
No, you were a team. So
we were a team. There were 3 of us.
And how was your competences? How was the team composition?
So one was the guy that was making PhD in Spain.
What's his strength? What was his
GPUs?
GPUs, yeah. We need a GPU guy.
He had good ideas also, and it was really fast at coding those ideas. I mean, I'm not that fast at coding ideas. I'm usually a slow starter, but he was really good. And then we had also one guy from Chicago. He had, as far as I remember, he had PhD in physics from Princeton, but he didn't say where he works or.
Yeah.
He kept it low.
He kept his real job low, but his strengths in the team was.
There are things like financial industry when people don't really reveal and their profiles are not public, right?
Yeah.
And other sectors as well. But okay. Yep.
And and his strengths was sort of
ideas.
Yeah.
So he was good in generating good ideas. Probably experience from financial industry.
So, for still, if you just go back to the mixture of experts kind of idea, how did you select the checkpoints? Was it just trial and error, or did you have some specific way to select? These are the
trial and error, or maybe rather like, okay, I've been waiting like 20 hours for this for this model to train. I will take a checkpoint, right?
Okay.
So or rather, you stop training at some point, you evaluate your model locally, and then you train a couple of hours more, and you see, okay, score maybe improved slightly, maybe not, and then you take ensemble of those, and you see, oh, the score is better than any of those two, right? So let's try another more. Let's wait a couple of more hours of training.
And what kind of tech stack were you making use of? Was you using TensorFlow, PyTorch?
Yeah, TensorFlow. Yeah. I mean, the data they provided were in TF records, so TensorFlow was kind of natural. So TF records is a binary format that is kind of developed by Google for TensorFlow.
And part of the framework, so to speak.
Yes.
And you use notebooks mainly, or what kind of?
No, that was just scripts, Python scripts at that time. And yeah, I had only one GPU, 1080 Ti. That was I bought it especially for this competition.
Oh, nice.
Yeah, I also track my energy use, right? So I write all my bills, and then I see the spike when I took part in the competition.
I actually still have a 1080 in my flat, actually, that I do run stuff.
What is a 1080? This is a GPU, of course, but could you elaborate?
It's two generations back.
2 generations back, NVIDIA.
6 years old, or how old is it?
Yeah, 2016, I think.
Yeah.
And was that state of the art by then?
Yeah, of course. But, it goes so fast these days. So
and
something that's 5 years old is so old.
And how much was what's the price of one GPU 1080 state of the art at 5 years ago?
I don't know.
10,000.
10,000? It's an expensive hobby somewhere as well.
Yeah, but when you are close to being in the money,
if you're in the money,
that was my bet.
Return on investment, it's okay.
Yeah, it did return, although Sweden took half of the price.
Cool. Great to hear about this really amazing example and how successful you were. And if you just were to summarize, if you were to redo it again, how would you do it? What's the learnings from doing all of this? How do you think you can succeed in a competition like this in the best way?
Plan the resources a bit better. I mean, I ran out of this space. Because also the checkpoints for the models were like 3 to 5 gigabytes in size, so they accumulate quite fast.
Did you have that big, fully connected layers that really?
Yeah, and you save all the weights. We are doing some also averaging of weights, like exponential moving averages and so on. So
over the layers or for checkpoints or for
over weights through steps.
From steps on each batch, basically.
Yeah. So that got expensive. I mean, it bloated the checkpoint files, because the checkpoints consist of all the model weights and everything that is in the model, so you can read the checkpoint and continue training. That's the idea of the checkpoint. So it's not only the results from the given point in time, but
so good resource management or planning or forecasting,
and maybe also better tracking of ideas, and because at the end we have to write kind of a submission for the organizers, because when you are awarded the prize, then you have to give the presentation to the organizers, right? And they ask you different questions, and you have to provide some maybe statistics or results of your different models, and if you didn't track it, you have to evaluate it. I mean, after finishing the competition, you have a couple of more days to make a write-up, so you can.
So if you have a structured documentation throughout, your write-up is way easier.
Yes, and the problem was like, okay, I've deleted some checkpoints because I ran out of disk space, and then I needed exact number how this model scored, right? So I had to rerun it even after the competition. But
so you still came up with some kind of architecture and 3-layered dense network or something. How did you come up with that architecture? Did you just try out different things, or how did you do that?
Trial and error, yes. And also you try to fit into resources again. So, I mean, GPUs had, 1080 Ti has 11 gigabytes of RAM, right? So if you try to fit a bigger batch, because you don't want to train for ages, and you want to...
Did you do any hyperparameter tuning things, or did you just try it manually?
You try manually in the beginning for a couple of times, maybe different learning rates, or... Yeah, we tried also changing learning rates along the learning, right?
Yeah.
But
and learning rate schedule in some way too. change it over time?
Yeah, but that was more manual.
Okay.
So if we would summarize this conversation now, for some of the listeners who actually has no background.
But also, I think we should also be, when we have a technical person like this, let's go into depth at some point as well.
It's nice to, and we did it now. That's the point. We did it now, and we can go. You want to go more nerdy a little bit more?
Yeah.
We can, but okay. So let's continue on the really deep side, because we have the really deep listeners.
Yes.
But then I think we should try to basically summarize, like an executive summary of this for someone who is not fully in the deep learning space. So please go deeper if you want to. But I also think if we can explain what this is all about for someone who's not in the know, it's quite hard, isn't it?
Yeah, I mean, because you need to understand what's the problem first.
Exactly.
Right? And you need to be a bit technical to understand the problem.
Yeah.
And
But this is an interesting conversation in itself. If we move further on when we finish this topic. I think this is one of the data AI gaps, right? The data literacy between business people that even be able to follow. It's a hurdle that you need to have data competence to some degree in order to start having a good conversation.
But then they don't need to know all the details, right? They're interested in the outcomes.
Well, maybe we should go there later, but that's a good topic then. So what do I need to know in order to work effectively with your data scientist guys for this to work? Do you need to understand or not? I mean, like, this is a really good topic, actually.
I think so.
But maybe we should finish this topic, or maybe after.
I just think it's so fun to go into technical depth, but perhaps we've gone too far already. But okay, so for this specific challenge, at least, you basically had a dense network, and you were experimenting with different techniques like checkpointing over time and creating a mixture of experts over different checkpoints and models that you had.
And moving averages of weights and different parameters.
Do you have any sense of what was the biggest added value of these techniques? Was it the moving average part? Or?
I think the moving averages and ensemble.
Do you still like ensembles? I mean, I know they are effective, but if you were to use it in Kambi or at in some professional setting,
if you are able to create like two different models which make predictions that are a bit uncorrelated and still have a good, like, let's say, target metric precision or whatever you use, then I think ensemble. Why not?
Good. Good
the main idea is that they need to be uncorrelated, right?
Yeah, exactly. Diverse in some way. So different views on the same. It's like having a group of 10 people trying to make a decision, and some people have different background knowledge. And if they make a combined decision, then hopefully you have a overall kind of more stable decision in some way.
Yeah, so like business people try to say that you should have diversity in your teams, right?
So now you have diversity in your models.
We have diversity here, right?
And the diversity in the model means in that they should be uncorrelated.
Yeah. So they make like deep learning models can use different architecture, or they can use different input features, or they can.
Before we move, I'd like to move into more of the tooling space and how to track experiments and things like that, because I think that's an interesting learning in itself. But perhaps we could bring up one more challenge. Is there some other challenge that you found extra interesting in some way that you could mention and talk a bit about, besides the video understanding challenge?
There was one about those satellite images. The company was sponsored by Statoil, and they had images from satellites. I make images because those are microwaves being sent by satellites, and they bounce back, and satellites read that, and you have just reading from of microwaves. But you can display them as an image, right? So then you have, depending of what color grading you pick, you can see some, let's say blue and green, right?
Did it have many challenges as well, or was it a single channel kind of two-dimensional?
Those were two channels. I mean, there was like horizontal and vertical. Right. So I know that by fast, I remember there are also 3-channel satellites that do also like some cross. So you have vertical signal, horizontal signal, and they do either cross or they do both at once. I don't remember. But there was some. You had to read a bit about satellites and how they do imaging from there. But the competition itself was about recognizing in those images if there's an iceberg or a ship.
That's one.
Oh.
Okay.
So
it's a binary classification problem, more or less. Iceberg or
Yes.
ship, right? Mm.
yes. So
This is a famous one, I think. Cool. And can you just speak a bit more? What was the name of it? Was it,
iceberg challenge?
yeah,
or
something like that. I think
something.
I've heard about that before. Actually, I think it's kind of famous.
So, I mean, 2 guys from Sweden ended up quite high in the leaderboard, as far as I remember.
Oh, okay.
I think one of them would work at Spotify.
Oh, really?
Kirill.
Oh, Kirill, of course. Yeah, he's another. We had him actually on the show as well. He's a good Kaggler as well. Cool. And can you just speak about how did you approach the problem and think more now, like if someone else were to were interested in doing Kaggle challenge and they see the problem, they see the data. Okay, they know it's images. They have a number of channels in that, and they should basically do a binary classification prediction from that. How do you proceed? What would be the first step that you take to start to
read up or Google if there's something similar being done in production, let's say,
read up
in the wild.
Like you do.
I Google. I'll try to find some research papers about identifying
Iceberg.
maybe not icebergs, but any kind of images, right, from the satellite, or how those microwave satellites work, right? What's the problem of having vertical and horizontal reading from the satellite? What does it mean, right?
So building up your domain knowledge,
or fundamental
you
problem
make sense,
knowledge, problem understanding.
Because often in those Kaggle competitions, you'll have some domain experts taking part, or you can ask competition organizers questions, right? So you have to know what they are talking about. And if you are completely new to a competition, you can wait like a week or 2. Then the forum on the competition will build up with a lot of domain knowledge and people asking interesting questions. Some of them also publishing like a sample models that you can start your journey from.
Yeah.
So the community is quite friendly and helpful.
Yeah, it's very, very friendly and very helpful, and that's a best place to learn machine learning, I would say. If you really want to do only machine learning, not data cleaning, DevOps, and all the things around.
Operationalizing.
If you not operate, but really modeling, right?
Modeling.
So hanging out with Kaggle, the Kaggle community is a really good school.
Yeah.
The community, yeah?
I mean, there's also one quite big Slack channel, Kaggle Noobs, and there are like 13,000 people there. And probably like 500 active in total. But there are a lot of people from the top of the Kaggle leaderboard there, and they are really helpful.
Okay, so you read up a bit about how the satellite imagery works, etc. And what's the next step that you do?
I mean, you set up your project, how to say, right? So basic structure, and you need let's say folders for input data, output data, different cross-validation outputs. Maybe set up some notebook, not Jupyter notebook, at a notebook to keep the track of your.
You never use Jupyter Notebook and these kind of things?
Sometimes I do, just if you need to plot something fast and get the feedback quite fast, it's more handy than script. But if you have some model to run for hours, then you prefer to do it from the script.
Yeah,
right. I mean, and nowadays there are also Kaggle. I think they renamed it from kernels to notebooks. So they have notebooks that run on Google infrastructure, and you can run your models there.
You mean in the Kaggle website, basically? They can provide
yes.
notebooks that you can use and access GPUs.
Yes, also GPUs, and without GPUs, also they have CPU versions. Some of them have internet connections or not. It also depends on the competition rules. So you may not be able to install, for example, some external packages. But yeah. But so you read up a bit about the competition. What is it about? Try to that's also important thing. Try to understand the target metric, right, because it's not the same from competition to competition, and you get some metrics are more strange than the others. Some are more familiar. Some you can use directly in your training because it's like differentiable and so on. It's a nice metric, but some are not.
Do you remember what the metric was for this iceberg challenge?
No.
But something like precision recall, AOC, or something like that, or R2 square, or
I'm not even trying to guess. I don't remember.
Okay.
Yeah, but try to understand the metric, and I mean they are repetitive. Of course, they are not making up metrics from competition to competition. So just try to find previous competitions that were using these metrics. So I mean, sometimes you can get quite a lot from checking different competitions. Like I think there was this they call it data science bowl, right? Like an annual competition.
Super Bowl.
Yeah,
data science bowl.
Yeah, something like that. So that's the idea behind it. But that was a classification problem. But if you check the metric and the history, there was a competition that used a regression, just a regression and just tuning the cutoff points, and that performed much better than any standard classification algorithm.
Really?
For this type of competition. So yeah, reading up about the metric, checking what has been done in the past. Yeah.
But okay, so and then you build your first model and you try to see what the performance is, and you try to iterate, I guess, as quickly as you can, or can you just describe,
What's the
how
process?
agile is the process? So to
And
speak?
what you need to do is build a robust cross-validation. Because, I mean, you are limited in number of submissions a day. And then if the competition is small in a way that the data set is small that you can iterate quite fast, then you will use those submissions quite fast. And you don't want to overfit to the leaderboard. I mean, leaderboard gives you some feedback, but that's a fraction of the whole data set.
And it's not the same as the target.
It's a fraction of this target, right? So it may differ a bit from the distribution of the data can differ a bit in the final, the one that is used for private leaderboard that will define the final standings. So if the distribution of the target variable differs, you may optimize for something slightly different, right? And although you see only one score on the leaderboard, you can.
But if you understand you correctly, you basically take the training data you do have and split that up into some kind of validation set at least, so you can iterate offline.
Usually you do a couple of folds validation, right? So 5-fold, 10-fold.
Yeah. Okay.
Depends on the size of the data set.
Yeah.
And then people, of course, do stacking and ensemble of those. So they train.
Do you move directly into ensemble models, or do you
No. You try it first, like how the single models perform. Because when you have to do the write-up, they ask you, okay, you made an ensemble of those 5 models. What were the scores of those 5 models separately? So you have to test them in some way, right? But if you develop the robust cross-validation, then you can see that, okay, your submission your test locally produces similar results to the test on the public leaderboard, right? And if you make a couple of submissions and you see that they go in the same direction, I mean, it's not that your score on Kaggle will go up and your local leaderboard cross-validation result goes down, then something is off. Maybe you should tweak your cross-validation, right?
Yeah.
So you need some stratification there, and there are different ways of.
And just for tech nerds out there, for this iceberg challenge, what was the input data? It was the 2-dimensional images in number of channels, and then simply binary classification. So what type of model did you use for this?
I don't remember what was the model.
It wasn't a dense model, at least. It must be some kind of convolutional model, right? Or
sorry. Yeah. You tried to do convolutional, but I also did some Fourier transformations on those signals, and use that as a separate input on the side. So I combined output from the convolution, and I think I had some full how do you call it? I lost the word. Like a long. You shape the matrix to be just a vector, right?
You unroll it, or you flatten.
Flatten. So I flattened the layer, and then I added those Fourier transformations on the side. And I took like a minimum and maximum from those Fourier transformations, because you could see if you did those Fourier transformations and took some averages from each image and you plotted that, you could see that iceberg usually, if it's a big iceberg, it cuts off the signal on the specific frequency.
So I'm trying to understand the intuition behind the Fourier transform. Normally, the Fourier transform has some kind of periodicity it's trying to detect in the data. And in this case, you have pixels that is unflattened in some way.
Yeah, but I mean, you have that's a object on the sea, right? So you have waves around. So you expect
waves,
maybe
I
there's
see.
some
Okay, so every row has some kind of periodicity in it. Okay. Oh,
I mean, you expect that maybe there is some difference between top and bottom of the wave, and then that the object that you are trying to identify will be, you can identify the height maybe, right? But then, so what I did, like for each, let's say, row of an image, I did a Fourier transformation, then took average of Fourier transformations of the whole image, and then I acted on that. So I tried to find some threshold that would say that it's a ship or not.
And you didn't even use convolutional then? So you just fed it into events or what?
I mean, I used convolutions on the side, right? So we had like I don't know how to call it, not CMEs, but two networks that diverge.
In parallel. So input were fed into two parallel branches in some way.
Yeah.
Okay. And one was the convolutional, and another one was the more Fourier feature engineering branch, if you call it that.
Yeah. But
cool.
In the end, I mean, a big part of the competition was also to identify that some of the test data were synthetic. So,
really? It was?
Yeah. So you could. I don't remember what was the idea behind it, but there was something like if somebody found some threshold or something in the name of the files that if you cut files with this in this pattern, then
also they could actually cheat because the data was not really real in that sense, or
there was not enough data, so some of it was synthetic. But if you identify the synthetic, then you get more real distribution of the data set, right?
So many tricks.
So there's a backdoor to the problem.
I mean, there are a couple of things, right, that you try to. Also, when you're doing your building your cross validation, you try to check or mimic the distribution of the test set, right? Not split the train set evenly, like make it stratified, in the sense that you divide the train set into different small chunks, right? And you don't want each chunk to have the same distribution of data as the whole training set, but you want it to have the same as a test set, right? Because that's what you aim for.
Yeah. Now I want to go in and
I'll stop here.
Now we have been nerding, going down and down and down, and I've been trying to follow, and I don't follow, right? Of course I don't follow because I'm a business person. At the same time, I want to follow, I want to learn, and actually. A main point I want to stress to everyone, by listening and trying to follow, even if I don't follow on the detail level, I follow concepts. So I think it's very helpful. Yes?
Sorry, I just reminded myself how they identified those.
The nerd was not
fake
synthetic.
I mean, they provided coordinates of where the image comes from, right? And they found that above some threshold,
it was synthetic.
I think that was the idea.
Do you remember the winning solution? What they?
I think the winning was also
You're so funny,
using
guys.
this altitude, right? So there are more ships here, and the lower you are, the fewer icebergs you have, right?
Yeah. Okay.
I mean,
But it's good. It's so cool. You get passionate down on the nitty gritty stuff, but I think there's a very healthy conversation we can have now. What?
Just one comment. That's why they call it data science.
It's data science. Yeah, data science. But if from a business perspective, how much does the business person need to follow, or what is the business person's job in order to work effectively together with the data scientist in this business problem translation? Because when we go down to into the convolutional network, of course, there's nothing I can do here, right? But what is my job as a business person is to help the data scientist, build good models or build good systems.
Don't disturb. But yeah.
What is my job? What is my job? To have a really good team. What is my job?
Define a problem in a sense that you're not defining a solution, but you're saying where's the problem.
Okay, and let's talk about defining.
Really, but not really what is the problem, but where is the problem?
But this, I think this, I actually have an anecdote where I had when I worked at a large utility. I came up and I had my 5 minutes in one of the export members. Henrik, you are running around in here. What's the problem? What's the problem we have in Vattenfall right now? If we want to we want to accelerate, and I said one thing. Right now, before let's talk about one thing only. We have a business to analytics translation problem. I said, forget about everything else. But right now, we in the business don't even know how to define, or we don't have a lingo to translate the problem. So this core topic now, how should I now define the problem so you can translate it for me or whatever? I think is really good. So what's the problem definition we need? What is a good problem definition from a business point of view? How can we look at that?
I mean, it's really, I think, case by case dependent. I mean, you cannot generalize.
No,
I think it's easier to define what the bad one is.
Yeah.
and it's many cases where perhaps non-technical people come up with saying, this is a solution you should provide. Right. We just wanted to fix this because this is a solution, please implement it. And they don't really provide what the end use case will be, which may require a completely different solution instead of what the business or the person that is not perhaps super technical may know of.
I agree. I mean, they try to ask you to implement the solution just straight away.
But let me be a little bit sharper then. I mean, leading question or leading hypothesis. I think typically when the business person comes with a problem, he is way too broad, and we need to go layers and layers deeper to make it into an algorithmic problem we can solve. So I want to increase sales. Come on, go and do some AI, increase sales. So where do you go from there? Where do we go from there? Because this is reality, right? Yeah. I heard AI can fix my sales funnel. Let's go. Where do we go? Let's take this as an example. What is a good problem that we can solve now? I think this is core. Yep. They don't understand how to define it.
I have an anecdote, but do you have an
idea?
Answer first?
I mean, I'm sure you have examples in your current. I want to look at this and this metric, and you need to then basically take it deeper, or
I mean, not really. I mean, we are more, let's say, software company, right? So people understand. Yeah,
you're more savvy already, maybe.
Yeah, I would say so.
Yeah.
Just to give a quick example, someone said we want to be able to do this kind of matching between people and. May be a bit abstract, so I don't reveal what I'm meaning. People and jobs or tasks or something, yes. And then they said, we need to use named entity recognition. I saw that's an awesome thing in NLP, and we
so someone
want, yes, we want to implement named entity recognition. Can you do that in the best possible way? And sure, we can do that. But then you think, what do you really want to do in the end? It's a kind of matching problem they want to do. And perhaps, named entity recognition is not really the solution to it. It could be some other way you can do it, which is much more, efficient, given the current way we can use AI. So I think that's a typical example of someone that is, focused in the beginning of a solution rather than describing the problem that you want to do in the end.
Yeah.
So always thinking about, what do you really want to use it for? Understanding the business problem is something I think every data scientist should always ask, Ask once and twice and three times, but how do you want to use it? Tell me, how you want to put this in production. What is the interface? What is the actual either user or programming interface you want to use it in? And go from that. Because that's so often misunderstood, I think.
Yeah.
I have a question for you. So how often do you speak with your data science teams?
Me?
Yeah. I mean, there is a data science team in Scania, right?
Yeah, for me, all the time, right? So we work as a business, cross business to engineering DevOps team. So I think that's how you start to fix this, that you work on a daily basis in a cross-functional team where someone has the business understanding and are used to talking with the data engineers and data scientists on a daily basis. Then this becomes less of a problem. but then you can ask me, okay, how often does a part of Scania that doesn't have a data science team talk with data scientists? Not so often. So it was a leading question sort of thing. Yeah. But are the typical problems, leading question, or type of problems that are more suitable to solve with AI, like matching and recognition problems and stuff like that? Or, can we give some hints or tips or thinkings like when is AI a suitable approach at all? Or when, forget about it, use visualizations, use something else.
When you have systematic way of getting the data.
Systematic way of getting the data?
Yeah. Because if you don't have the data, then you will have no use of it, right? Even if you create a model, then if you don't get new data to make predictions on, then what's the use?
Could you give an example? I agree, but could we give an example to make it more tangible?
I have some chatbot examples. It's my favorite hate topic to speak about.
Chatbots.
And chatbots, it's another, it was really what I was thinking about for the named entity recognition part, actually. But it's so many examples where people say, we have huge amount of data. We have saved every kind of mail that we have, and we have saved, blah, blah, blah. But they don't have the annotations for it. They don't know what was true and what was false. They don't have anything to train on. No. And they don't understand that they also need that to be able to train a model to do something, usually. And I think it's a typical example of people don't understanding, if you don't have the right data and actually high quality type of data that is not noisy. I mean, another example is, I think, finance. You say, we have 10 years of data, no problem. And we have the target, it's just looking 2 days ahead, we have so much data. Well, yeah, but the quality of data then, do you have any kind of predictive power in the data at all to really make this useful? Probably not.
So it even starts here, right? That you need to work together with your data scientists to understand what data you need and even start cleaning up or even starting tagging and annotating and making other metrics in your data. I think it's a huge hurdle. What do you think?
How do you think in Kambi? I'm not sure how much you can speak about details there. I know you can't, of course, go into detail, but do you work closely with data science people and the product teams that you have, or how does that work?
Depends on the use case. So sometimes we work on our own stuff. And sometimes, because sometimes you want to create something and show that it works, then they can bring it to the product. I mean, it's rather you create a proof of concept, right, and show that it works, and then it can be productionized. Yeah. So it doesn't have to be, fully fledged final solution that you could put straight away into production.
So right now you have a centralized data science team that you lead as well, and do you have other people also embedded in some product teams, like analysts or something?
No, analysts, yes, but yes. I mean they're not. It changes. Yeah, they used to be. Now I think they're not, but they are assigned to some teams. But,
And what's the difference between a business analyst and a data scientist in Kambi?
Analysts don't create models, I would say, and we try to create models to predict, automate, or... Yeah.
So the analysts would work in slightly different tool sets, maybe? Or
you may say that, tool set doesn't have to be different because, they can still use Python or query the same databases, right? It's rather that they have more descriptive role, right? So they prepare presentations or reports
BI, visualizations.
Some product was rolled out. What's the performance? Did it change or not? How have the KPIs changed?
Yeah. So the main difference is the predictive modeling. Would that be fair summary?
Yeah.
Cool. I'd like to move to another topic.
Let's. I think it's an important topic how we frame problems, but it's also hard to. It's very abstract, and I think my main advice is that, it's the Toyota Kaizen.
Yes.
Ask why 4 times. When you think we take it again, and then I think you need to work over time with data scientists until you start recognizing what is an AI problem that can be solved with AI, and what is then ultimately data and annotation needed.
Yeah.
Because you can solve
perhaps
this.
a question then, to continue on that topic is really how do you prioritize, the work that you do in a data science team? Or how would you advise people that, this is something that a data science team working centrally in a company should focus on? How do you choose?
I mean, if it's a new team, right, and like it doesn't have its position in the company, then get some low-hanging fruits, right?
Yeah.
But that usually comes either it's very hard if you take people from outside of the company, right, and put them into that's your data science team and let them solve the problems because they don't know what are the problems.
The domain knowledge.
Yeah, the domain knowledge. Yeah.
But how much should be coming from the data science team itself, so saying this is something we should spend time on, and how much is coming from management team perhaps, or how much is coming from product teams, or
it's there is no rule, I would say. So the idea is, the data, as I said in the beginning, I came to Kambi for data, right? The data is really broad, and even after those years of working there, I don't have the full understanding of everything. And also the domain develops very fast, so it's very hard to keep a track of what has changed. And after you get to know the data, you can come up with some problem. What doesn't work, what works, and where you can do some improvements, right? But that comes with time. So I guess if you create a new team in a company that doesn't have experience, domain knowledge, then probably the problem should come from product owners and management. But if the team got experience with working with the company's data and the resources they have, they may come with their own problems, definitions.
But so when you brought in a data science team, did you now learn, because I think this is a long learning journey, that you build up domain knowledge, but you also build up a better understanding of the data. You might realize there is missing annotations, so you start doing things a little bit differently that allows you to do more and more fun data science. Is that a fair summary, or as you grow and learn your data, do you understand what you have and not have and what you can add?
In a business like we have, you wouldn't annotate the data yourself, because then how would you get it in production? You would sit and annotate in real time. No. So you have to make use of what you have, or see if there's a way to buy maybe annotated data. If there's no annotated data to buy, then maybe some development team should,
But in reality, your core production systems and the systems where your user is using it, it's about making sure that things are captured and tagged, so you get it right and classified or tagged. So
that usually come with a problem, right? You don't try to tag everything you have, because that would be also a waste of resources. So first you come with a problem, then you see, okay, I don't have the data for that. Can we get it, right? Yeah. And then you can put this. You can suspend this project, and they can work on getting the data.
Moving into one of my favorite topics.
This is interesting. This is because this is the chicken and the egg, right? You know what to do, you know how to do it, but the data points are not really there. What do you do?
But it's like with science and research, right? You have a lot of ideas, and you have to scrape them off because some of them don't work, or you don't have the data, or maybe it will take years to get the data.
And I think you are jumping on active learning techniques.
Yes.
So let's go there a little bit.
Now, but let's take a concrete example. I think it's easier for people to follow then. So I'm trying to just make up an example now in Kambi. Let's say that you want to classify people that are using Kambi's systems in some way, saying they are either, I'm just making things up now, super engaged people versus passive people, working. And you want to classify that, just knowing, is that type of person or not? And you don't have the data or the annotations. You have the data, of course. You can have a lot of input features about each user and what they do and how they act and what they do. But you need the actual annotation, the label for it. And then you want to figure out how to fix that. And you said something, it's hard to do that when you have in production, and perhaps you don't want to do it yourself as a data scientist. But if you still would like to do, if you would like to have these annotations, how would you go about doing it in the best way?
I guess label part of the data, train a model on that, and have a proxy for production. So have two models in productions, like two-step models. Yeah. One to predict the label that you want to have, and the other two that uses this label.
Mm.
Let's say you may say somebody is high spender or low spender, right? You can just have a threshold for that dummy model,
like
right?
a simplified model.
And you can do that in production. So.
I'm not sure if you heard about these terms like active learning, etc. That
is it the same like online learning? Like you have been advertising that you have feedback straight away?
No, it's a bit different. It's simply, you said, I think, a very important thing before is that you can never annotate everything. It's too expensive and you would never have the time and resources to do so. So then the question is more, if you were to have some guidance in what data points to annotate, how would you find out, what data points should need annotations to just maximize the performance of the model? Mm-hmm. And it could be, very simplistic one is simply to look at if you just do predictions, using the current model you have, some kind of score from the model would indicate a lack of confidence. So you could use some kind of max entropy or some kind of confidence measure from the model prediction saying, I'm really unsure right now as a model if this is yes or no. Therefore, please annotate this one. And that could be, there are a number of these kind of active learning techniques to try to help you to guide saying, these are the data point that is of highest need of annotation right now. Do you think that could be a useful way for Kambi in some way or for other companies that wants to build up like annotated data that can be used for training models?
But then you'd end up with a very skewed data set, right? With those highly, let's say, risky or highly, the ones that needed really annotation. And what about the rest? Right. So
I like your question already, but okay. So I can speak forever about this, but I shouldn't. But I think one of the problems with active learning is that they only focus on the very unsure, unconfident kind of data points, and you want diversity with that. So otherwise, you just annotate the exact same data point that are very, very similar, and the model is always unsure about. So you just annotate like hundreds of data points that are exactly the same, and the model really doesn't benefit from having one or 100. So having an increased diversity is one thing, and there are actually techniques like bolts or batch knobs and what's not to try with that. But I think the exact opposite, what you just said, is very important, saying, what if you have wrong annotations? What if the model is super confident saying, I'm 100% sure this is a high spender, but then you have some annotation saying it's not actually. Then it's probably a wrong annotation, and you need some technique to catch that as well. I think that catches, I think, in a very important problem, which is not captured by Kaggle competitions, which is actually something I think is very important and telling in some way that in Kaggle and academic data sets, everything is super cleaned up. Everything is assumed to be perfectly ordered, unless you have this kind of synthetic data that you can identify and abuse in some way. But in real life, then labels are noisy. You can't assume every label is correct, and you must handle that.
That was the case of this YouTube competition also.
Okay.
The labels didn't have to be 100% correct. You didn't know which were, which not. Yeah. They had I think, a team dedicated to verify those labels for the test set. So they would be correct, but only for the test set, not for everything.
It's a super interesting problem, and I wish more research were being done in this. And actually, this connects to Kaggle as well. And I think one of the first presidents was this Jeremy Howard, if I'm not mistaken, of Kaggle, and he's actually the founder of Fast AI these days. But he said an interesting thing about the research being done in deep learning, and that's basically is that. He more or less said, I'm paraphrasing a bit, that the current research in deep learning is a complete waste of time. And what he meant with that was, if I'm also guessing a bit what he meant, but basically saying that it's so much research being spent on just obtaining 1/2 percentage point in the leaderboard for some academic data set, and that's not really what the need is from industry or more practical use cases.
I agree.
Yeah, you would?
Yeah, I would admit it's like if you look at the papers, everybody is chasing the state of art, right?
Yeah, exactly. The SOTA record,
maybe just shuffling the data set a bit and it will give you different results.
Yeah, or just putting together an ensemble model.
But how do you? What do you think? Like if you go back to real life, what is the real life problems that is worth solving or researching when you think about what your real data science work is all about in production? So what are the things that are hard or things we should be better at? I think annotation and active learning techniques. I think, and we talked about self-supervised learning techniques and stuff like that is super, super important. What do you think?
Access to data, right?
If
you even take the coronavirus, in China, they just took all the X-rays from however many people they wanted, and they built a model to recognize if it's real pneumonia or caused by coronavirus. In Europe, you have GDPR, and that would be a problem.
Oof, I'm biting my tongue right now. But it is certainly an interesting problem. How do you solve this kind of, you still want, of course, to preserve the privacy of people, but then you have the other challenge of, imagine all the opportunity cost of not being able to use AI when it could be used for so many good things. But we need some kind of
we need another model that doesn't do this so polarizing. There needs to be understanding of opportunity cost that it's actually worth.
Yeah, but then who can decide who makes the money on it, right? And Google getting like a lot of medical data from NHS. Pretty much for free, and so why Google? Why not some startup?
Yeah. So speaking about Google, I think we could move into the next topic, and this would be the AI divide topic potentially, and then Google buying Kaggle, for example, and what the implication of that would be. And we've been speaking a bit about the concept of AI divide before. Have you heard about that concept? Or so it's basically that we have a few set of top tech giants in US and China, Google, the Facebook, the Amazons, Microsofts of the world. Apple, sorry. And also in China, of course, you have the Baidu and Alibaba and Tencent and these kind of really, really big tech giants. And they know they have all the data, they know how to use the data, they have the knowledge, they have the research groups, they have, everything
legal
they
department.
They have legal departments, and they can easily comply with GDPR and whatnot. And they basically are the most valuable companies in the world right now. So this kind of divide between the few that have all these kind of knowledge and access to data and are able, and the infrastructure in place to make use of it is just increasing, accelerating a bit. And then Google with so much money and they can buy Kaggle, and hopefully they don't destroy the purpose of Kaggle, or what do you think the future will be now when Google owns Kaggle, for example? Do you think still it's...
I think the only thing that changed was that there are some research competition that you don't really get the money, but you get invitation to the conference, and you work on a research project.
So if you were to guess, why do you think Google bought Kaggle?
Maybe also for recruitment. Because there were competitions that the sole purpose was recruitment, right? Facebook had 3 or 4 competitions like that. So the people from top 100 got an invitation for an interview if they wanted.
Couldn't they do that without buying Kaggle, you think? Couldn't they simply scrape the Kaggle website and see who is leading that? Or why did they need to buy Kaggle for that?
To get a constant flow.
Maybe.
You can scrape
data access.
You can scrape.
No,
more,
but it's
right?
an interesting point, because why did they buy Kaggle? What's Google's angle to buy Kaggle?
Microsoft buying GitHub.
I think it's a similar actually question.
But GitHub for me is a library and or the whole, it's a community, and you find all that.
You have it across. You have Vipro buying Topcoder. Topcoder is very
Vipro,
similar to Kaggle, and GitHub was the same, and LinkedIn is the same. It's access to customers, right, and know-how.
Yeah.
So
here we have a database of 1 million people interested in data.
It's 1 million people. It's the database of 1 million people interested in data.
Curated database.
Curated data. Yeah.
Self-curated.
No, because
who would not like to have a database of 1 million data scientists?
No, maybe that's a good enough answer. I don't question.
But
but it's a little bit like to buy GitLab or GitHub, then you're buying into the sort of core infrastructure framework or basically tool sets that people work. So Microsoft or they want to be part. They want to own the data scientist toolbox. I get that. That makes sense. Microsoft is a tool company, and here is a big part of the tool now. GitHub.
But speaking about Google and Kaggle, I think it might be they might have bought a feedback loop for developing their product, right? So they have collaboratory, this Google kind of notebooks that work on Google infrastructure, and they have Kaggle kernels, so they can improve collaboratory based on that is a commercial product, based on the feedback that they get from all the data scientists on Kaggle.
Now this is interesting.
Is that the purpose, you think? But Colab is so successful anyway, isn't it? Or
I don't know. I don't have the data.
Well, what is your understanding? Why did Google buy Kaggle?
But before Kaggle, they didn't have collaboratory. They didn't have Colab,
yes,
right?
I'm not sure about the order, but it was developed separately at least, right?
Yeah, and they are still separate product. I mean, when you talk with developers from Kaggle, it's a completely different product. They have different roadmaps and so on. But maybe they use learnings one from the other. But
at some place, this is a talent war we are dealing with, and I think that has to be one part of it. What do you think, Anders? Why do they? Why do they?
I'm just a very cynical person. I shouldn't even speak about that publicly. I think there are some other reasons for it. But let's say it's just because they want access to the best talents in the world, and hope that's it. I don't really buy that, but yeah, let's hope so.
But you have another story.
I mean, they created those data sets, right? So maybe they wanted people to organize some data sets for them, right? And they had some plan. Because Google was always saying they are organizing the information.
But do you have a slightly different understanding of you? We don't need to go there, but say yes or no at least.
I'm hoping that's the case, but I'm not sure it is. Yes.
Okay. All right. Let's move.
Yes. Okay.
AI divide a little bit.
Yes, AI divide. So this is the whole, we have the problem. I mean, I think it's wrong to call it a problem. I think it's really good that we have the tech giants. What would the world be without the big tech giants that we do have? They provide so much good for the world, and that's really good. And I think it's kind of, we're just being jealous in some sense, saying, why can't we have a tech giant in Europe or why can't we in Sweden actually we do have a couple of tech giants like Spotify.
But I don't think it's that they are good, that is the problem. It's that the rest is not accelerating.
Yes.
That's the problem. I mean, and I think the divide becomes a problem because a lot of good companies with a lot of people employed, they're so far behind, so they will be eaten up and disrupted in a way that will be more painful than if some of these companies started to drive their own data and AI journey. I mean, my hypothesis has always been that we will have a better society if more companies catches up to the few. Like this huge segregation in know-how is a little bit scary. What do you think?
I mean, the progress was always coming from the big ones, right?
Yeah.
But not all. Startups have done some amazing things. And I remember some Google executives said, we're not really afraid about the enterprise like Apple and whatnot. What we're really afraid about is a startup that's come up with an idea.
I was about to say that they don't have to stay big forever, right?
Yeah.
No.
Okay.
So continue. Sorry, we interrupted.
No, I was about to say that the innovation and the big stuff always. I mean, in one sense, big companies they don't dare to risk too much, but they do have money to risk. So,
what's your if Kambi were to become the super big tech giant, so to speak, in Europe? Do you think this is hard to answer, I know, but still, if we want to have more tech giants in Europe, what would be your advice in making them be, closer to what the tech giants are? Do we need to do more research? Do we need to be more like innovative in different ways? Do we need to make sure that we have an understanding of data and AI in a better way? Do we need to be what are we missing today to come closer to that?
But if you think how did they build the companies in US, they first do what they want and then they kind of comply to the law, right? Or like they don't ask for permission, they ask for forgiveness.
Oh, right.
That's the way. In Europe, I think it happens the other way. So you try to comply with the law and do everything correctly from the very beginning. And I think that was not the case in the US, right? So
and China perhaps.
China is another issue.
No, so some point here is that at some point they have been taking risks, they've been doing things, and I think it's a good summary. Sometimes ask for forgiveness instead of permission.
But also, like if you are the data scientist in a company, you sometimes should probably create something on your own and show that it works.
Yeah.
Not that you ask if you can do it. And
so you can take that from a macro perspective down to a micro perspective. That if we need to try things. We need to be allowed to try somewhere. Mm-hmm. And of course, then if for companies who think this is sensitive and there are opportunities how you create a sandbox. Even in the public sector, we talk about sandboxes a lot. So you can always, if you have the right frame, you can create the environment to do it. How should I put it, safely? But I think this is a big hurdle, right? That how to create a safe environment to experiment is one way to look at this.
So we only have 15 minutes left, and we have a number of topics, and I'd like for perhaps you to choose, a bit what you would like to be able to talk a bit about, and let me just name a couple. And I think one that you mentioned is basically the regulation problem that we have, mm-hmm. and that could potentially hurt innovation, and what's going to happen in the future when we know a number of new acts of legislation is coming up in EU, for example. That could be one topic in how that impacts, companies mm-hmm. in Sweden, Europe, and Kambi, for example. Innovation could be another topic. How can we really promote that, for example, Kambi and the data science team you have are allowed to innovate by allowing themselves to come up with ideas that may not be driven by people that don't understand the tech and as you mentioned before, come up with the wrong ideas. Instead of speaking about the problem, they speak about solutions. So how do we really come up with innovative solutions in a good way? That could be another thing. I like that we hopefully have some time to speak about the singularity and more philosophical topics about, what will happen in 10 years or 20 years when AI will start to become even increasingly intelligent and things like that. If we stop there, any topic that you would like to start
with. What legislation is coming?
Oh, well,
we are not up to date.
Yeah, I can speak of this for some time.
Let's go there a couple of minutes.
Yeah, okay. I've seen some papers that's not public yet, but still we had a white paper that was released earlier last year from Europe that spoke about AI specifically, and they, for example, spoke about the differentiation between high risk and low risk AI, trying to say that some type of AI or some sector of AI is more dangerous than others, and they should be regulated differently than other sectors, or whatever, how you slice that type of AI application, they will have potentially a different set of regulation. And you could argue, how should you do that in a good way? What's the implication of having regulation that is discriminatory in some way, depending on the sector or the user or whatever you slice it with? And then you can speak about GDPR and then the problems that had, which has great intentions, but then implementation-wise, it may not be perfect and actually resulting in the AI divide that we have.
Yeah, GDPR in Sweden.
Yeah.
That's a good one. GDPR in Sweden.
Yeah.
Sometimes I feel it's a joke. if you take into account this certificate you can get from Swedish Radio and Television Commission or whatever you name it, right? You have all those services when you can Google anybody, right?
Yeah.
And they use this certificate that they pay like, I don't know, 200 euros and they can publish databases that they own, right? Which is pretty much personal data that they could never publish under GDPR. But this certificate protects them on the constitutional basis or something like that.
Yeah, exactly.
Right.
I would like to add on that. So right now you can get the social security number of every single citizen in Sweden, right? Not even the 4 last numbers. I didn't think that is possible, but actually it was. And it's protected by the law. So no GDPR will actually do that under paragraph 6 or whatever it is.
So it's completely nuts.
Yeah, it's nuts.
Yeah.
Okay, so the only thing that you cannot get of this person, you got everything, how he tall he is, where he lives, who is his wife, her husband.
Which is all...
Everything except the email. So as soon as you get the email, GDPR. But everything else you know. How much money does he make and all this other thing.
But how can that be possible? How can we as companies be in such pain in GDPR and at the same time this is completely legal? I cannot wrap my head around it.
If we take Kambi as an example, and it would be great to hear your thoughts about this, and you're a B2B company, and you actually have a problem that you need to apply by GDPR to I would say, a greater extent than B2C companies that have direct...
We pretty much don't have any customer data, as far as I know.
Oh, good luck for you, or
it's
so nice for you.
Yes.
Sorry?
It's a B2B.
Yes, it's a B2B.
Don't you have users that you work with?
Unibet has, or their end customer has the data.
But you mean, but in your systems, you still have to have user or data, but on user level, or no?
I mean, but we don't have personal data, right? Not PPI, not personal protected information, or how do you call it?
Yeah, PII, personally identifiable information. Yeah. Okay, good for you then. But let me speak in general. So normally, I think it's kind of a weird that a company like Facebook or whatever kind of company can say, here's the terms of service. Please press accept button, and then we can use your data to do whatever we want. And then if you have another company like IKEA or ICA or whatever kind of retailer, retailers may be an exception, but anyway, they have to apply by GDPR, and they can't simply put up a long terms of service agreement that no one ever reads but still accepts. And that causes they just circumvent the whole purpose of GDPR by having this kind of weird.
But Facebook also needs to do that, right?
Yeah, that's my point. I mean, they can use data for so many things by simply having a large terms of service that people just agree with, because they never read it.
And the retail e-commerce site, they could potentially do that, but no one does.
Yeah.
So that's why they can't use the data.
They're so afraid about it. They don't have the legal resources to defend if someone were to challenge them, but Facebook does.
But so one theory is that IKEA should have their 10-page paragraph like Facebook.
Well, that's the way to abuse the regulatory system we have. Yes. So if they want to abuse it, then that's what they should do. Right?
And that's the idea for the startup, right? You create as long terms, and
we just use GPT-3 to generate the terms of service,
Exactly.
Put it on the website, and then you have all access to the data you want.
Oh my God! Yeah.
Okay. Regulation is a tough topic.
But a little bit, the strange thing is a little bit back to what you exemplified. How can we have PII data legally in some cases, or how can we find that data, Goran? I mean, like what you highlighted, we can find all data on everyone.
Yeah, I will Google myself. Okay.
I mean,
just go to upplysning.se or something.
Yeah.
Whatever.
Yeah. So, you Google yourself.
Okay, and then you find. Let's say Medinfo, probably will find some of this, but there is
even your age,
yeah. So you have my age, you have my personal. If I click here, so these guys are selling it. In some of them, you can actually. Sorry. So these guys are selling my what is called social security number, right? So there are some other companies that are actually not selling it. It's just actually for free.
Yep.
So you have my social security number, you have my telephone number, you have my age, you have my address, my salary, and that is not personal identifiable data. I don't understand. And I cannot stop this. I cannot call them and say like, hey, you should delete me from this.
Why can't I call this guy and say, I don't want
because
to be
according to the law, this is authentic, this is public record.
Data inspection says the same. I was writing to them.
But it's completely nuts, right?
It is.
Yeah, it is nuts. So welcome to the GDPR era. Yeah.
And data inspection is no more. They changed the name.
Yes. What was it? It's called. We talked about it.
Integritetsmyndigheten or something like that. I don't know. Anyway, perhaps a final, more philosophical topic. I still love to hear your thoughts about the singularity. And so singularity in some way could be defined as at some point in time in the future, AI will be on a human level scale. And it could also be defined in a different way, which I think is more interesting, saying no matter how intelligent it is, but it will be a point when it becomes out of control, saying
you can't pull the plug.
You can't pull the plug anymore. It could be, I would say that's more dangerous because the general part is one thing, but it's more dangerous just to imagine that you have some set of drones that can go around and shoot people and you can't pull the plug on them. And that can happen today because we have the AI to do that today. And potentially we could never pull the plug if they just could, generate themselves. So in some way you can define singularity in different ways here. And it could be dangerous if we don't have a way to make sure that they basically do things in the interest of humans. What's your thought about singularity? Is it something that you have been thinking about or scared about, or
not thinking? I think it's still science fiction.
Mm-hmm. You think if you were to guess, some point where we potentially will lose control, or that we will have human level type of intelligence in AI, how many years ahead do you think?
I don't think I will live.
Really? That's far ahead?
Well.
But lose control, we can easily see it's happened already a number of times. Like we have a number of crashes in the stock market, for example, because we lost control of how these kind of high frequency trading systems work, etc. So we know if you don't regulate things properly, it will go bad, right? Mm-hmm. So in some sense, it's kind of a grayscale, what happens. And luckily we've been able to handle a lot of threats already. We were able to regulate, for example, biological abuse. Mm-hmm. We were able to regulate nuclear power. We were able to regulate, genomics, and I think we can do the same for AI. But it seems like we are not really thinking that much about this. If we take like self-driving cars? I mean, I think that's not as dangerous example as like a stock market example, for example, that could crash the whole world economy in some way. But would you feel, let's say in 5 years, and let's say you have a car that drives better than the average human, would you prefer to sit in a car with a level 5 self-driving, machine than a human?
I assume I can drive better than average human. So. It depends. I mean, there are too many age. Whenever I think about those cars, I think they are developing them for like climates like you have in California, right? Not what you have in Sweden. Mm-hmm. If you have white roads and everything is white, how will it cope with it? Mm-hmm. I mean, I've never seen any kind of movie commercial or anything with self-driving car in the winter. Why?
Maybe. So but do you think it's just a matter of time before that happens, or do you think it will never happen, or what's your thinking about when?
I mean, it's a matter of time, I guess. But
if we take the time axis here, and I think when do you think the average self-driving car will be better than the average human-driven car?
It depends what the measure. Because if you take like
number of accidents or number of fatalities,
if you take like Tesla, they are reporting that they have a little number of fatalities or accidents
10 times safer already
per kilometer. But then if you take into account that a lot of those Teslas drive through like highways, and then you don't have accidents there; they're just making kilometers, so they make the denominator high.
Yeah. But still, if you take the worst case, like a proper average or kind of edge case you can think of, when do you think the average self-driving car will be better than humans?
I don't know, 15 years.
15 years.
Yeah. I mean, like an average car that you have in production, right?
Yeah.
Because I don't believe you can have this level 5 with just cameras. I think you need something like LiDAR or something like that.
You go against Elon Musk here now, but
he puts LiDAR down.
Yeah.
If you have tough road conditions like mist and I don't know, heavy rain.
But humans have no lidars.
Yeah, they don't.
So if we just compare to humans, wouldn't they still be able to do better than humans at least?
But then you would replicate like fully human vision. And humans, let's say, they drive the same way over and over again and they remember it. And I don't think the cars at the moment do. So you know where could be the hole in the road, right? You could have passed by the bus. You left the bus stop and you've seen there was a hole in the road, right? So when there will be mist, you will know that the hole is there. But
imagine if Tesla remembers that and it's not from a single car, it's from 10,000 cars that all drive over the same pothole. And they can collect that data much quicker than a single human ever could, right?
Yeah, if you had that. But I think at the moment they are not retraining on all the data they get. They don't get data.
But they could just store it in a database, right? Here's a pothole.
Tesla had the problem when they had Spotify for free in Tesla, right? And a lot of Norwegians were coming to Sweden for holidays and then suddenly they have to pay for roaming, right? So I don't believe they are sending back the training data. So I think that's far in the future. Maybe with 6G, it will be cheaper and faster to send the training data back.
Well, Elon thinks differently.
But then
we'll see how.
But then GDPR and others. Right?
Exactly. GDPR could be the problem, perhaps. Should we move? The time is already 7 now, so let's move to the final questions here. And Marcin? No, sorry. Okay.
Marcin. I will say instead. Yeah, Marcin.
Martin, what's next in your life? What's happening personally, professionally? Something happening coming weeks, months?
My older daughter, we are preparing her for exam to a music school. So that will be this weekend. And beside that, nothing really happens. Work and kids.
Working kids. So life is working kids right now.
Yeah.
In what? In a balanced way, you would say?
It depends on the day.
Yeah, it depends on the day. Good answer.
But this working from home works quite well. I mean, you don't lose like 2 hours commuting.
There are benefits, of course.
No, but there are people who don't like staying at home. For me, it works.
Yeah.
You think we will come back to the old situation when Corona is under control, so to speak, and we have vaccinated the most population? Or
you would prefer to work more from home?
I would prefer to work from home, but I like to travel a bit. Back home to Poland also. I mean, it probably will be more kind of become like a more common cold. Yeah. Maybe the fatality will be brought down, and they will find some medicine to make the symptoms easier. But yeah.
And Spotify just announced the work for the VFA, the work from anywhere kind of policies, meaning that even whatever Corona situation in the future, you will always have the flexibility to work from wherever you want.
But then which salaries do they give? Do they give San Francisco salaries or New York salaries or
Sweden for all?
Well, I shouldn't go into that topic, but you should compare it to perhaps Sweden type of salaries at least, right?
Yeah, that would be nice. But then there's other tax legal problems.
Yeah, of course.
Can you spend 1 month?
But I applaud Spotify to try.
Yeah.
And to push the boundaries in this way. I think it's...
Yeah, but the question is how far is a PR stunt and how far they really want to do it.
Yeah.
I mean, they may say they do it, but they don't employ new people at the moment. It's like, okay.
True. Very true.
Cool. Marcin, who would you like to have on this show, and who would you like to have us bringing in and you listening to?
I don't know. No, seriously, I don't know. I mean, honestly, I don't know that many people in Sweden, right, who could come and talk.
Yeah, you have to be physically here as well. That's a limitation.
But I think I joked about it. But you went to university with an old colleague of you,
Kava.
Yeah. I think I will help you.
Him.
I will help you.
If he comes to Stockholm, we should bring him on the show.
We should bring him on the show.
Yeah, but we need coronavirus then.
Then we need to coronavirus then. Yes, that's true.
Marcin, it's been a true pleasure, and I think a lot of people have really loved hearing about all your, tips and tricks about Kaggle competition and your expertise on that.
Thanks for teaching me about Kaggle. Thank you.
Thank you.
Yeah, it's been a true pleasure. Thank you again very much.
Thank you very much.
Thank you.